All right, example 2 from section 8.1 on perimeter, where we have a kite that is drawn in which the ratio of the lengths of the two sides is 3:2. So what that means is that for every 2 units of measure on this side of the kite, there are 3 of the same units along this one. So that's what that ratio is, and that's why we have 2x and 3x here, because for every 2 units here, there's going to be 3 here. So whatever x is, we multiply that by 2, and then we multiply it by 3 here, because that's what the ratio is of 3:2. And we know that the perimeter of the kite is going to be 40 inches all the way around. Then we got to find the lengths of the sides. Well, they only give us 2 sides, but since we know it's a kite, we know that this side has to be the same as this adjacent side here, and then this side right here has to be adjacent to this, has to be the same to this adjacent side of 3x. So that's just because of what we know about a kite. That's the definition of a kite. These two are the same, and then these two are the same. And the perimeter is 40. So we're going to take those 4 side lengths, add them all together, 2x and 3x, 2x and 3x, and they add up to 40. And then we just have basic algebra, combine our like terms here. If we have all of those x's, add them together, we get 10 x's, and that's equal to 40. So therefore, x is equal to 4. That's not the length of any sides, that's just what the value of x is. So if we want to find out how long this side is here, that side length is going to be 2 times 4, because x is 4. So this side length here is 8. And then the other side length is going to be 3 times 4, which is going to be 12. And the ratio of 12 to 8 is the same thing as 3:2. So that's where that ratio comes back into play there. And we can see that this ratio of 12 to 8 is exactly the same ratio as 3:2, which is what we want, because that's what the ratio is.